All right, welcome everyone to, I think it's the 28th CIVO meetup. Yes, I'm right. And I'm very excited about this meetup because we're talking about machine learning on Kubernetes. And obviously, AI is it's everywhere. And it's interesting to hear from other companies how they're utilizing it, and especially for developers, how they're making devs' life a bit more easier. So we have good folks, Savo and Shive here from Pieces.app. You can check out all the links in the description or just go to Pieces.app. But yeah, today we're going to talk about deploying large language models, and we're going to talk about how they grow in size and complexity and all these other challenges. How do you tackle those? Some best practices. Obviously, it's a live webinar, so we'll be answering questions live as well. If you're not joining us live, it's being recorded as well. You can just check it out on civo.com or on our YouTube channel. And we have a nice little demo as well for CIVO machine learning services that Shive will be sharing, and how Pieces can help you. But a lot of things, and let us know where you're joining from. I see some people from Nepal, the US, so nice. Pretty good. And yeah, before we get started, let's do some quick intros. I'm Kunal. I work as a development manager at CIVO. That should be enough. Sao, take it away.
Yeah. Hey, everyone. Savo here. I'm CEO and a technical co-founder at Pieces.app. Happy to be here. Thanks for having us, Kunal.
Yeah. Hey, everyone. Super excited to be on this webinar. I'm Shvai. I've been working as a developer advocate at Pieces. Just completed 10 months. So super excited about to complete my 1 year, and super excited to be presenting a demo here.
Amazing. So before we set the agenda and just talk about the challenges and do some live demos, there might be a lot of people for whom Pieces is new, and not just Pieces, but we're also very interested in learning about how you're utilizing AI, what you're doing with AI, and being a big AI company, what are some of the things that you've learned? So we'll cover all of those shortly. But Savo, if you can give a quick intro on what Pieces does, and we recently launched the new features in live context. So these may sound buzzwords to some people, so a little demo would be nice. And can you share a bit more about what Pieces does?
Yeah. So I mean, Kunal, you put it very, very kind of simply there. I would say there's so many complexities around building products that are kind of AI native, right? And if you think about it, like a lot of the things you used to do previously that were manual, they can really be kind of automated through AI capabilities. And our approach at Pieces, and one of the reasons that we're doing some work with CIVO, is we wanted to start out, especially when we're working with developer materials, everything is on device, right? Developer materials, they have a large amount of intellectual property. They might have security constraints, maybe some privacy stuff, and so on. And so we wanted to say, all right, let's start with everything across Mac OS, Linux, and Windows, and then let's build up incrementally where it makes sense and where we are compliant to tap into the cloud. So the demo I'll kind of show you today is on device, and then we'll talk about on-prem, and then Shive will take us away with where we're going with some of the cloud stuff. And it'll cover, both training the models, but also using them, right, and deploying them across local devices and cloud servers. So I'll go ahead and do a quick demo here, and I'll share my screen. I'm going to share my entire screen. Okay, fantastic. So you can probably note here, I was doing some work last night, and this is the natural flow for developers. Tons of browser tabs. You've got like a lot of windows going on, all different types of stuff. And then you've got your IDE, right? And so multiple projects inside your IDE, and then multiple tabs inside those projects. And so oftentimes like this kind of feels like a bit of chaos, but what I just showed you really represents three major pillars across the work in progress journey. So we started out building Pieces a couple of years ago for a very simple kind of phase one approach. And that is, maybe you're on the internet and you're looking at some documentation, maybe an open source package, and you want to just save that to Pieces, right? So I'll go ahead and I'll show you where we started. Phase one was all about humans being able to save something, right? And so, yeah, basically for my entire development career, it looked like this. I copied it to my clipboard, I opened my notes app, and I pasted in there. And that's a pretty crude experience because we can do so much more with AI. And so we'll show you how we've trained kind of models to run on device and make that paste experience really world-class. So I'll go ahead and launch Pieces for developers, or Pieces OS. Apologies. There we go. Get that booted. And then Pieces OS is this system that runs, again, like kind of in the background on your computer, and it powers all the integrations and everything, and it holds all the brains, if you will, of the platform. And then I'll launch our desktop app, which is Pieces for Developers. And this is the app that most people interact with day in, day out. So that bit of code that I have on my clipboard, I'll go ahead and just come into the desktop app here and I'll paste it. And what you'll see happening is very quickly, we're determining, hey, that wasn't actually just plain text. It was actually code. And it wasn't only code, but it was dark code. So that's, again, the first implementation of AI is what is this thing that I just saved? And from there, of course, we're going to use AI to deeply enrich it. So giving it a title, and then, of course, giving it tags, related links, annotations, suggested searches, you name it. Now, the one thing to note is that all of the capabilities of Pieces are able to run on device. And what I mean by that is we'll go ahead and we'll train models in a cloud like Sivo's kind of fully managed ML pipeline. And then we'll export those models and we'll run them locally in Onyx or in TVM or things like that. And so you can see I can actually use a completely on-device mode, and all of the capabilities here where I might copy a snippet or save something or whatever else are equivalent. So I'll take this sub snippet and I'll paste it. And so, yeah, we did the detection. We're going to start to enrich it here, giving it a title, descriptions, links, everything like that. So that was the first kind of implications of AI for us. But I'll go and I'll switch to the settings again, and I'll turn the cloud stuff back on, which is pretty exciting. So we'll get into phase 2, which was for every material you have saved, you might want to start a Copilot conversation about that thing. So I can launch and kick off a Copilot chat. And it's going to use that snippet as context, and it'll, kind of kick me off with a couple suggested queries. The thing to note here is that, of course, you can, again, use different cloud models, ones that might be hosted on Sivo, ones that might be from a third-party provider like OpenAI or Gemini, and then ones that we might fine-tune and make available offline like Mistral, Phi2, Llama 2, etc., which is, again, supporting that air-gapped kind of constraint. So you can use every feature in Pieces completely connected or completely offline. But yeah, that was phase 2. A lot of developers, they like to come in, they like to basically, generate code, and then they like to save from their Copilot conversations. So what you'll see here is we're doing some Windows Form stuff. We're going to generate some C# code, looks pretty robust. And then we got some notes, and I'll go ahead and say, all right, this code's pretty interesting. Maybe I want to save that. And there you go. You kind of got this generate, iterate, and curate loop. Again, all this is powered by machine learning, from the enrichment to the generative process and so on. And then, building on phase 2 and phase 1, we kind of identified that there was a problem around, developers oftentimes don't realize they should have saved something. Like if you're reading Sivo Navigate docs, you're like, okay, that YAML config is really important, but you might not make a note to like save it for later, right? It's a conscious process. And so for the last 11 months, we kind of got into this ability for Pieces to understand everything that's going on across the operating system. We call this the workstream pattern engine. And so phase 1 was about humans saving to Pieces, but phase 3 now is about Pieces being able to save things for you and have a deep understanding of your real-time context. So that pattern engine that I just mentioned powers live context, and I'll go ahead and show you what this is. So basically, I can pop over to the browser, and maybe I'll look at a different package here, like image picker. We can see, this is just what developers do. They come in, they take a look, platform support. They're like, all right, how do I get started? They look at some code snippets and so on. And maybe you're not noting too much, but you're comparing a couple of different packages that you might want to use for your implementation. So I can jump back to Pieces here, and live context allows me to understand things over time. So I could say, what was I just researching in Chrome for images? And I can ask these questions that are like temporally referenced. So just researching, right? That might mean a moment ago. And I am on a MacBook Air, so it's a little bit limited compute, but we're gonna go ahead and kick out a response here. So I was researching the image picker. We've got some details, permissions, so on and so forth. I'll give another kind of interesting use case, which is I'll pull up Google Chat here, and I'll go to my infrastructure standup. This is another idea where Pieces is aware of the work that you're doing in the browser, the work you're doing in those collaborative environments, and then the work that you're doing in the IDEs. So if you're talking about an error in GChat or Slack or Teams, and then you run into that error in the IDE, Pieces can connect the dots there. So I'll just go ahead and open up Pieces again. And I'll say, what is everyone up to in infra chat? And I'm asking it pretty casual, pretty vague questions, but you get the idea. Pieces is going to have that context. It's going to do some processing right now, and then it's going to give me an output. And I'll wrap the demo here pretty quick. Okay, hit or miss. I will say I am on staging, so sometimes it's not always perfect. But either way, I'll jump over to the IDE and we'll do another kind of example here. So I'm in my main.dart file, and maybe I'm doing an implementation, and I'll go ahead and just throw an error. Error. Oh, actually, I'll just do this in a unit test. So we got this widget test here, and I'll go ahead and say throw exception. This is a test exception for Civo live stream. And this will really show you the power of AI. It's quite crazy. So I'll go ahead and run this widget test here, and we should get this error. Let's see. I think my computer's a little sleepy. We have a really large release that's coming up on the 10th, and so my computer has been running hard. But we got some stuff going on. It looks like the error was not related. It seems like a Dart library JS interop problem. But either way, I can go over to Pieces and say, what is going on with the error I just got in IntelliJ? And we'll give it a second. I do have my coffee, but we don't have coffee for MacBooks right now, unfortunately. So we'll see. Oh, okay. So it looks like it has a general understanding, not exactly what I was looking for, but you kind of get the idea. We're trying to just connect the dots across Mac OS, Linux, and Windows in a way that doesn't make you paste the context all the time. And that's something to note, right? So we'll talk about, setting up machine learning on Civo Cloud. We'll talk about how we're looking to kind of use cloud infrastructure to improve some of this stuff. But it's hard to get this right. And so you want to have a really efficient pipeline to train, fine tune, test, etc. And that's such an iterative process in the AI space. So, but yeah, that's kind of a quick update of Pieces. I'll jump back to the live stream here, and then we'll get into some more stuff. Go ahead and pull that up. Go ahead and hide. Might have lost my live stream. Apologies. Where did we go? Nope. My bad. I have no idea. And this is the developer chaos. Oh, here we are. Perfect. All right. We're back. So yeah, bunch of windows, bunch of stuff going on. I can't even figure. I wish I was like, hey, which tab is my live stream in? And then just ask Pieces and it says, here's the link, which would be great. But you kind of get the idea, building a product that has such a robust level of machine learning is no short feat, right? And so you're going to need really, capable cloud stacks. And I think Civo is doing a really interesting job, both for their ML managed stuff, but also their Civo stack, which allows us to ship these models on-prem, inside of a certain environment, right? Like the DoD or a banking environment and so on. But yeah, I'll pause there. And I think we got some more stuff coming into the technical side.
Amazing. Well, thanks for sharing, Sabo. And obviously, we'll dive deeper into it in the demo.
Yeah.
But one common question we get is like, what are some of the common challenges when we talk about deploying machine learning models? And I mean, obviously, there are many ways to do it. You use on-prem, you use your own like public cloud, for example.
Right.
But yeah, what are some of the challenges and just something that folks should keep in mind?
Yeah, I think, when it comes to like either training a large language model or publishing one or something like that, I mean, there's so many components in the supply chain, right? And so you've got your data lake, you've got your data cleaning pipelines, you've got your analytics pipelines, your performance testing pipelines, and so on. And so, for us, like the main thing is, where do we put all this data? And is it co-located with the compute that's going to be training on it, cleaning it, processing it, et cetera? And then can we actually, fine tune a model and then serve it? And then when it gets to the point of serving it, you might have maybe 10 users, but that might very quickly scale to 1,000 users, right? And the thing about large language models is they're not uniquely designed right now to serve a bunch of different users on one instance. So you're going to need to get into some horizontal scaling. And then that has implications on cost. It has implications on the noisy neighbor effect, where you have a lot of co-located compute that is running in parallel. And so you might have certain latency effects if the system is getting flooded. And so I think like, that just covers the surface of what it looks like to actually, serve this stuff. And if you imagine, how many times ChatGPT goes down, at least in the last couple of weeks, it's hard, right? It's really hard to do, and it's really hard to get right. So excited for the stuff Shivay is going to be sharing here. And yeah, I'll jump in if there's anything that we particularly use as well.
And we have close to 300 people watching live. So thanks for everyone. And we are already getting some questions. Indranil is asking, what impact does Pieces have on device performance? I have an 8 gig RAM. Could it slow down my system?
I think all AI will certainly slow down, any system. I would say we do have we have a lot of users that are on kind of, older devices or devices that are low compute, low memory. I would say it probably could use anywhere between a gig of RAM, just like, quietly. We do have this ability in the Pieces dropdown to optimize your memory, and that'll clean it up. But if you're going to load a local large language model, that might be pushing it, because local large language models, even if they're like 7 billion, in parameter size, they're going to use anywhere between 4 and 6 gigs of RAM. But yeah, I mean, we have really great cloud models, so certainly try those out, which is pretty great.
Cool. Yeah, that's a question go ahead, but I'm happy to share a bit more about what Civo offers as well.
Yeah, I was just going to say, we're going to get some really good demos from Shivay on the nuances here, right? When it comes down to developer experience, when it comes down to just getting up and running fast, I think we'll see really how easy it is with Shivay's demo. But Kunal, if you want to add to some of that.
Yeah, and some other similar questions around automatically scaling resources based on AI workload demands. So let me just quickly present my screen. If you can see the Civo ML tab. Yep, so you can just go to civo.com/machine learning. We have a Kubeflow as a service, and we have cloud GPUs as well, which I'll talk more about later. But yeah, it's backed by our own infrastructure, and you can train your own models. You can use VS Code, Jupyter Lab, all sorts of things. I think one of the main problems that I see people face is that, especially let's say when we talk about Kubernetes, is they don't have enough experience working with Kubernetes, and that's what one of the USPs of Civo is, that even with a minimal experience, you can get up and running. Like, for example, the user experience, the dashboard, it's all pretty simple. And I think that ties in really well with machine learning as well. And if you have any existing machine learning projects, you can utilize Civo ML to scale those in the, on a larger scale. Again, we take care of the infrastructure, and it's all backed by the Civo, compute and all the other things that we have to offer. But yeah, developer centric. So you have all the resources that you need in your environments to build and to scale open ecosystem. So we prioritize open source quite a lot. And the other thing I want to mention is there's no vendor lock-in. So we don't have any like data transfer fees, egress fees, or anything like that. So you're not tied into the Civo ecosystem, because we believe that you should stay with a cloud provider because you love them and not because you're forced because of vendor lock-in. But yeah, you can check out the documentation, machine learning tutorials. Regarding the GPUs, I can quickly answer the questions that we get that tie in with the GPUs. We have some partnership with NVIDIA. We have all the latest GPUs like N100s and A100s and 40S and the other ones. But again, yeah, no vendor lock-in over here as well. Regarding cost, I would say around a third of price compared to hyperscalers. But not just that. I think one other thing we have to talk about is the environmental effects. When we talk about GPUs, it's not good for the environment. So we have a partnership with a company called Deep Green. I don't know if anyone's heard of that, but you can check it out on the website, which is Google Deep Green. So what happens is that they take heat generated from the cloud GPUs and they use it to do day-to-day tasks like heat the swimming pools and other things. So when you use green GPUs by Civo, you will see the dashboard turns green, and all the instances and everything that you're running, be that Kubernetes clusters or GPUs, it's running on 100% renewable energy. enough talking, but I think you would love to see some more hands-on stuff. And that's where Shive comes in. So Shive, take it away. And then please keep sending your questions in the live chat, and we'll be answering those in the end.
Yeah, rock on.
Absolutely, super excited. So I think a lot of active engagement, and hopefully we can put on a good demo. Before I do that, I think there is this ritual that everyone should follow. This is something that's special that only Sivo provides, which is praise the demo gods. So I have this mug. I think it's important that everyone who is presenting live demos should have this. So I just wanted to give a huge shout out for the branding on that.
I definitely needed one of those. I was like, classic staging build.
Yeah.
I should have had my lucky mug. That's great.
Yeah. That's
Demo gods are with you. Good luck.
Yeah. Perfect. So I think we should be good to get started. Now, I think before we jump into deploying an open source large language model with the help of the Sivo Kubernetes cluster, we also talk about the different kind of offerings that are there. I think it's also important to understand that, of course, when it comes to like deploying any kind of workload on top of Kubernetes is complex, right? It's not something that if you know even the basics of HTML, CSS, JavaScript, you can go ahead and do that. Like there is a learning curve involved. You need to learn about things such as basic Linux commands. You need to learn about networking, community networking, operating systems. You need to learn about basic Docker, and then of course the core understanding of how Kubernetes works. And then of course the general way in which you would package together your application will be you have your application code, you create a Docker file, you package that Docker file as a Docker image using Docker build. And then once you have that image, you host it inside of a registry. It could be the Docker hub. And then you simply go ahead and create a Kubernetes cluster. And from there, now you're able to actually serve that image on top of Kubernetes, which is this orchestration tool. So this is a basic primer on what exactly is Kubernetes. And of course, now when it comes to taking a look at these machine learning models, which are these really large scale models that can run easily in sizes of 5 gigabytes and above, depending on the modern day large language models, which can easily cross even tens and hundreds of gigabytes in size, depending on how large their context length is. So you need like really impressive compute, and even the typical Kubernetes pods that you will see usually come with CPUs. So in most instances, if you are trying to deploy these large language models on a cloud instance, you would need to configure your Kubernetes clusters with GPUs. And so we'll also just jump a bit briefly into how that actually works before we actually kick off the demo. Now, a fun thing that we'll also do today is I will be using Pieces Copilot, for which I have already turned on the live context. Now, what I did was that I really enjoyed this particular article, and everyone who just wants to actually get started with using Sivo and you want to deploy your first ever Kubernetes cluster, definitely take a look at this particular blog, which is deploy your first Kubernetes application through the CLI. And again, as the way that the live context will work is that as you are doing anything important on your device, the Pieces OS will be able to capture the most important parts of your workflow, so through screenshots, and then it will intelligently understand what exactly are the most important bits, and then you can actually query that through the live context feature on the Pieces Copilot. So what I did was this, before this, I made it kind of, I was, just going through this particular blog myself, which kind of covers, you need, of course, kubectl in order to, run your Kubernetes cluster locally. So for example, if you want to create a cluster on Sivo Cloud, so first thing you'll do is you'll go to sivo.com, you will sign up for the account, and you'll create a cluster. And then you'll also have to download kubectl locally, and using which now you will download your kubeconfig file, and you will set it inside of your local CLI. And then, of course, there are primarily 3 different things that you need, which is a deployment file, which basically means what kind of container image you're going to be using. So it will go ahead and deploy that on a particular Kubernetes pod. And then you would basically have the service. So that's the backend. And then finally, you'll have a deployment file and ingress. So ingress will be for setting up your networking and deployment, so that now you can actually host it on, let's say, using a load balancer. You will have an actual endpoint which you can now hit which is being served on this Kubernetes cluster. So I found this to be really helpful. So I can actually go ahead and just ask a prompt which is summarize the and I can perhaps just copy this particular URL or the name of the blog, summarize the blog that I was just reading in Chrome, which can give me more details into, and again, given the fact that right now I'm using the GPT-4o model, you can also use any of the local large language models that you might want to use. So then, it will take some time. And as you can see that it is able to understand that it is on sivo.com. So it is able to capture all of the important information. And I had a separate conversation where, then I also asked it, can you share each of the steps focusing on the deployment, service, and the ingress file? So that's a basic gist of how you can leverage Pieces Copilot with the live context feature, and we'll also dive deeper into when we go into the hands-on. Now, what I'll go ahead and do is I have a few slides that I wanted to kind of put together. Right now, typically the way that you are actually running these machine learning models is through CPUs, and of course GPUs if you are running more compute-intensive tasks. And you might also use TPUs for more specialized models like the Gemini and the Gemma models from Google. They work particularly well on tensor processor units. And primarily, just to understand this on use cases, that typically whenever you are setting up any Kubernetes cluster, it will only have CPU support by default. So whenever you are integrating GPU support for Kubernetes, and we will also have a small demo where we'll show you how you actually set up the operator for, let's say, an NVIDIA-based GPU on top of a Kubernetes cluster. So we'll handle that very shortly. So in that case, there are primarily the two different things. One is the host level components. These are essentially what the GPU is providing to you, which is basically the NVIDIA container toolkit and NVIDIA GPU driver if you're using NVIDIA-based GPUs. And then on the Kubernetes side of things, you'll actually need a couple of things, which is the Kubernetes device plugin, which will be able to actually find or locate the actual GPU device itself that's sitting somewhere in your entire cloud cluster. And it will be able to discover that, right? And then you'll be able to leverage, like, let's say you'll be able to connect the GPU inside of a particular node where you can now define in your YAML, which kind of looks like this, where, for example, if you want to see, what you essentially do is that within the YAML file that you define when setting up your Kubernetes cluster or defining your cluster, you will define that inside of the containers, and specifically you'll share based on whether it's NVIDIA or AMD, you'll provide the image name. So in this case, if you're using NVIDIA, you're using NVIDIA CUDA, and then you'll define how many, you can define how many GPUs you actually need. So depending on how big your use case is or how complex your workflow is, you can either define one or two GPUs or even more, depending on how large your Kubernetes cluster is. So that's the typical way. Now, of course, when you're basically setting up Kubernetes cluster with the GPU config, you essentially need to install the GPU operator on top of the Kubernetes cluster. And in case you're using the NVIDIA side of things, then you have to basically install the NVIDIA drivers, which will basically have the NVIDIA container toolkit. And in order to verify that, yes, it has successfully been installed, you'll use the SMI, NVIDIA SMI, to just confirm whether the cluster or the node inside of a Kubernetes cluster actually has successfully installed the NVIDIA operator. So in this case, the way that we'll basically do it inside of the Civo cluster is we do have this repository provided to us, which is basically a CPU, a Civo GPU operator Terraform file. So this essentially has Terraform config. For those of you who might not know, Terraform is essentially infrastructure as code. So it is a way to basically deploy or automate the deployment of your DevOps architecture. So whether it's your Kubernetes clusters, your Docker or ECS, EKS instances, right? All of those, or in this case with Civo, where you want to deploy your load balancers, all of that can be automated with the help of Terraform. So what we'll do is, before we actually jump into the live coding of setting up this GPU operator on top of Civo, I'll also just quickly go into my Civo UI. So I'll just quickly go ahead and open my dashboard. So here what you can see is primarily, as Kunal also kind of showcased, that we typically, the way that if you want to set up either GPU-based Kubernetes cluster, so we have the section of the NVIDIA GPUs. So you can actually set up a standalone NVIDIA-based VM, which will have a GPU cluster. Or if you want to set up a GPU-based Kubernetes cluster, you can also set that up. So if you want to do either of these two, you can go ahead and manually do that as well, where you can select based on the GPU. So you'll have the ability to select, a GPU-based cluster. You can also select a normal CPU-based cluster as well, and go through this manual route where it will basically create the cluster for you. But of course, one thing that to keep in mind is that at this very moment, whenever you actually create a GPU-based cluster on Civo, you cannot. It does not come pre-configured with the GPU operator. So NVIDIA operator does not come pre-configured. That is why we have this GitHub repository for the Civo GPU operator Terraform file, which will automatically not only create a GPU-based cluster on top of Civo Cloud, but it will also actually handle this basically setting up of the NVIDIA GPU operator on top of the cluster, so that now you can leverage it inside of deploying your any kind of workload that requires use for an GPU. So what I've already done is I've created this code space that is already up and running, and we'll just follow the particular steps that are given right now, because this is something to keep in mind if you are planning to use the GPU-based cluster. So I just wanted to kind of spend like the first 5 minutes talking about this, and then we'll jump into actually deploying the we'll actually deploy the Llama 3 model on top of the same GPU cluster. So in order to basically do anything when it comes to using the CLI for Civo Cloud, you need to actually set up an API key, which you can go and find inside of your settings. So if you go over to your settings in your profile and you go to security, you can easily just set up an API key. So I'll just go ahead and click on the existing API key, and you can set up your own when you sign up. And you also do get free, I think $250 credits on Civo Cloud whenever you sign up for the first time. So even you can actually set up and try out the same demo that we are running today based on your use case. So as the kind of, the README kind of suggests, so the first thing is that we'll create a new file. And over here, let me go ahead and create this new file, which will be the terraform.tf-vars. So this is important to basically set up in so that you can use this particular token when you are actually setting up your cluster. So I'll just quickly go ahead and configure this over here. So I'll just copy this over. So as you can see that now we are good to go on this side. Now what we have to do is that we also actually need to install Terraform. So I believe that I might not have Terraform. So we'll just go to the HashiCorp guide on installing Terraform. So we'll just quickly install Terraform over here inside of, I think since this is a Ubuntu cluster, let's go ahead and install this inside of Linux. So let's just go ahead and copy these steps. So Terraform, of course, as I mentioned, is required for you to use the infrastructure as code automation to deploy those clusters and not have to manually work on getting things such as your networking, all of that, because all of that can be a bit tricky. And even if you make one mistake, then debugging all of that can be a bit difficult. But that's where you can actually leverage Pieces Copilot, because that will not only be able to actually see your code, but also be able to, if you're using the live context, it will be able to see the exact error that you're actually getting. And using that, you'll be able to get the entire context of both your code and the error that you have. And that way, it will just make it super easy to run across. So let's just quickly finish these steps in order to get Terraform installed on our cluster. So I think we should be good to go. And if I run the final command, we should have Terraform up and running. So we should probably just have another couple of seconds. All right, perfect. So we have, I think we have Terraform installed. Perfect. So now what we just have to do is we have to go into the infra directory, into the TF folder. So this is where now So typically what ends up happening is that whenever you wish to use Terraform, you have to basically first initialize Terraform. That will also install all of the relevant providers. So in this case, I'll just go ahead and do Terraform init for to initialize Terraform inside of my project. And then when we basically use a Terraform plan, it will see what all resources that actually need to be created. Or if you have already actually used Terraform in the first place and you have deployed your resources, then you can also still use the same Terraform plan, because it will be able to understand that if you have already deployed certain resources, it will just automatically update them. So it will not create new resources unless you specify it to actually do it. So once we have initialized, we should go ahead and use the Terraform plan. And here we'll just simply again post our CO token that we have just created. And this will go ahead and now just plan out what all resources actually need to be deployed. And finally, what we'll go ahead and do is we will do a Terraform apply. So this is what will go ahead and actually deploy our resources. So again, this can usually take around anywhere from and I'll just go ahead and say yes. So since this is actually creating the actual clusters, it can take anywhere typically between 5 to 10 minutes. So the reason that it actually failed was that I already had created this background, because of course we have a limited amount of time. So I had already deployed this particular cluster right over here. So as you can see that when you actually deploy the cluster, it will show you that it has successfully deployed. So you'll get all of the resources. And just to kind of show you what all things we are actually deploying, so we have a bunch of tests running. We have the network, we have the firewall, the actual Kubernetes cluster itself, and the GPU operators, all of those, right? So if I go back into my Kubernetes section within my Sivo cluster, perhaps I think I had deployed in the London region, I should have my GPU cluster operator Sivo. So this is the one which got deployed, and I just deployed it like half an hour ago. And so that's one thing to keep in mind, that this is how you would basically set up a base cluster with the support for GPU, because that is something that is important to keep in mind whenever you are deploying or you're leveraging a GPU based Kubernetes cluster with the help of Sivo. Now let's go get into the fun stuff, which is basically going to be deploying an actual cluster. So the thing over here is that once you have basically configured your Kubernetes cluster with a GPU, so of course you need to basically have a YAML file. So there are multiple ways that you can actually go about deploying a project on top of the Kubernetes cluster. So you could basically have an app, which is a Python app that will have your source code with the large language model of your choice and with the actual endpoint. And then you can, as I mentioned earlier, basically containerize this using Docker. So first you'll create the Docker image, then containerize it, and then deploy it on top of Kubernetes. Or the other way is that you could also define, if you already have an existing image with you, so like a Docker image, you can just directly define that inside of a Kubernetes manifest file, which essentially contains of both the deployment and the service file. So these are used for actually deploying and then being able to actually host it on a particular port. So for instance, within the Pieces, you get this really nice feature of saved snippets. So if you are, like, let's say navigating through different docs websites, if you are perhaps going through, I guess, Kubernetes docs, right? So I could be going through the Kubernetes docs, and perhaps I find this really important code snippet during while using the CLI. So I can very easily, what I can do is I can use the basically the PWE, which is the Pieces web extension, and save code snippets out of the box. And for instance, when you're doing a lot of deployments with the help of Kubernetes, you might need certain basically some pre-configured YAMLs that you might have to actually use every time you deploy a new Sivo cluster. So very easily you can go ahead and use the Pieces web extension. I think I actually didn't have that installed, but I think that will be good to have it installed again in this particular browser. So if you want to install, you can install it for Chrome or whatever browser that you need. So in this case, I'll quickly go ahead and install it for Chrome. So I'll just quickly go ahead and add it to Chrome.
Yeah, Shivey, I will say when I'm doing configs, I mean, that's probably the number one thing I save to pieces. And like, it's so crazy the amount of time where I'm like, where did I get that config from? What site was it on? Things like that. I mean, YAML, like my pieces is like filled with so much YAML and like so much JSON. It's wild.
Exactly.
Nice.
And
That's-
again, that's something to keep in mind that especially if you're a DevOps engineer, right? If you're and of course, live demo we'll have the updates coming up, so that's always fun. So hopefully we should have this running. Okay, perfect.
No
All
worries, no stress.
Yeah. All right. So
And then these are just pro tips, because if you have as many tabs as I have open and as Shivey has open, like it's just nice to be able to fire and forget.
Exactly.
I will say that.
So once you basically have pieces installed, right? What you can do is, so I think I was here at this documentation. I think I should go back to this. Oh yeah. So for example, now if I want to save this, I can just quickly go ahead and click on Pieces Copilot and save this particular snippet to Pieces. And now if I go back to my, to my pieces over here, you can see that I just had this same snippet that I had found on the website, and now I can simply go ahead and copy this over and reuse this inside of my VS Code or any other extension that I'm actually using. So similar to this, I had already like created a snippet specifically for being able to actually deploy Llama 3 model. So here is an example of how a standard Kubernetes manifest file would basically look like. So there are essentially two different components to it. The first one is this deployment component. And over here, what you'll see is that we can define whether the YAML is actually a deployment YAML file or a service-based YAML file. So deployment over here, as you can see, is that it will deploy this particular container with this image. So this is deploying the Civo Docker image that will be actually hosting the Llama 3 model. So in this, I have the environment file. And over here, we have also actually defined the GPU that you'll be using, right? And similarly, we have a second one, which is the service file that's specifically for deploying this as a service. So in this case, for example, if you're running your application like as a Flask application, so typically a Flask application will be served on the port 5000. So you can very easily go ahead and serve this on that particular port, whichever port you want to define it on. So this way, if you have your these code snippets saved, now it actually saves you so much amount of time, not having to go back to the Kubernetes documentation or for instance like Civo documentation and clicking and copying that that particular snippet, because YAMLs, as a DevOps engineer, you're essentially dealing with day in day out, right? Most of the work is actually using these YAML files, and these can go crazily complex. So this one is just
Yeah, Shivey, I was going to say like two things. Click on the origin site in the context preview, because for me, it's like the snippet represents like a part. And then I'm like, okay, like it might be in your other window.
Oh yeah, that might be, I guess I can copy it.
No worries. You can go to the gallery view and try that.
Oh, yeah,
there you go. But yeah, it's like, okay, where did this snippet come from, right? And then kick out to that original repo, kind of go through the larger docs a hand. But it's like, okay, I know I'm looking for this type of YAML. And the other thing too is, this is my favorite, is like search by snippet. So when I'm using like JSON or YAML or whatever else, you can go to like global search and like copy a bit of that YAML. So yeah, you could do it like that. But my favorite is like, copy some of the YAML. Yep. And then go over to global search real quick. In your drop down. So the drop down at the top where you go to the Copilot.
Oh yeah, the global search. My bad.
Global search. Yeah. And then click the drop down right there. So it's that one, search by snippet. Now you paste that YAML, and now you can kind of see everything that is even remotely related to that config. So really nice way to say, hey, I know it's related to these keys or these setups or whatever. I'm going to go paste that and then find the actual larger config in Pieces, which is pretty cool. And then kick out to the repo and backtrack.
And as you can see, that this is basically the the snippet that I had saved, and it can directly go to the source as well. So I mean, if you're kind of deep linking in this way, I think it just makes it super easy for you to be able to search for those really pesky large YAML files. So as a DevOps engineer, I think like this is a super useful tool to be able to augment your, because I know like when you are deploying even if you have one small mistake in your YAML file, for example, the load balancer did not deploy correctly. So that can take, 15-20 minutes at least to just try to debug what might have been the issue. But if you have your pre-configured YAMLs, it's very easy to search for them. So yeah.
Awesome.
Anything else that you wanted to add to that, Savo?
No, I was just saying awesome. I mean, like, really, really great. I'm pretty excited about the large language model deployment here.
Yeah. So far, we have been giving you kind of a preview of what it's required to basically, first of all, set up a cluster on Civo, set up the GPU, and then of course now technically what you can also do is you can take this YAML file which I have over here in my save snippets. So you could essentially just copy this over, have, like, let's say save this inside of something like a manifest.yaml file and use kubectl -f and then apply, and then this particular manifest file, and it will automatically take care of deploying that. But of course, we just for the time's sake, you can actually also again automate this with the help of Terraform again. So in this case, we have this particular repository which you can quickly go ahead and clone as well, and we'll be sharing the resources with everyone. So here, what we have is basically a template for you to kind of cover. So the idea here is that we, for example, if you have a complex app such as, where you will have a main file with that's going to be deploying a Llama 3 model, and in this case, this particular demo will actually have two things. So it will have a UI where it's like a ChatGPT based UI. So it's an open source client which is similar to ChatGPT, and then you can actually run any type of large language model that you wish to actually deploy. So in this case, what you just have to do is, if you have this particular repository, you just simply go ahead and I'll go ahead and click over here, and I'll basically go ahead and create a new code space for me to quickly go ahead and run this over here. And I'll just quickly go over, how to again set it up. So basic setup is again fairly simple. We are essentially again going to be using a GPU based cluster from Civo. So if you already have your Civo based, and I'll go back to my settings over here and grab my Civo API key, which is required for this particular demo. So in this case, again, the similar thing that you need is whenever you're setting up the Terraform, you need to be able to create the terraform.tf-vars file. So I'll go ahead and quickly do that. So I'll use the terraform.tf-vars file, and I'll simply do the same thing that we did before, which is just quickly save this particular secret right over here, and I'll just replace this. All right, perfect. And now there are two things. So of course we have just to kind of show you what we are actually going to be deploying. So this is basically the new chat. This is again deployed via the Civo cluster. So I have the Civo cluster already running over here, which is this LLM boilerplate, because just so that in case the demo fails for some reason, we have the backup already running. But just to kind of show you like what exactly we are going to be deploying. So it's essentially the application has two parts. We have the actual large language model getting deployed on top of a GPU cluster, but we also have this web UI that is being served, and this is the actual web UI that you can actually see. So in this case, what you might see is that surprisingly, this is a UI that's very similar to a ChatGPT like interface. So this is, I think, as far as I remember, it's called as Open Web UI, which is completely open source, by the way, and you can deploy it, self-deploy it. So everything that we are using right now is completely open source, including Llama 3 as the LLM that we are going to be deploying. And as you can see that you can actually select between different type of models. So if you were to change your config to use some other model, you can very easily just have the container image of that particular model and just replace it, swap it, or even add more models if you wanted to quickly switch between different models. So this is the UI, and I can interact with it. I can ask it who built you, let's say, and just kind of confirm that that it was actually built by Meta AI. So you can actually see that it is running completely fine. And if I go into the actual cluster itself, it already took care of setting up the load balancer, which you can find over here. So this is the public URL of this deployed web UI, which is the open web UI, which is connected with this Llama 3 model, which is running. So this is the deployed link on this public UI. So this is the demo that we're actually going to be deploying. So now there are two ways. We have our actual code inside of our app.py, where what you'll see is that we have this particular route where the first thing is that we have Ollama, which is another open source tool that can run local large language models. But one limitation of Ollama, of course, is that it is just a tool to actually run local large language models. But what you get with the capability of Pieces Copilot, being able to run it locally and have support for models like Llama 2, is that you have that entire ecosystem experience where you can very easily plug it in with your VS Code extension or any other extension for that matter, and with the desktop app. And we are also bringing in support for Llama 3 and Gemini models as part of our product hunt launch. So super excited for that. And probably, Savo can talk more about that in a bit once we conclude the demo. So we are basically having Ollama actually serve the Llama 3 model. So what we'll do is that it will download the artifacts of Llama 3 from Hugging Face. And there are different types of Llama 3 models with different context sizes. So depending on whichever you want to use. So what it'll do is that on the actual Kubernetes cluster, it will run the Ollama on this particular endpoint, serving the Llama 3 model. So it just helps you to serve that particular Llama 3 model. And at the same time, we're also actually going to be running the OpenAI. So that's where we are using that. And then we also have a Docker file, which you can see that if you were to just go ahead and navigate to this particular file, you just have to go ahead and simply Dockerize or containerize your app.py file. So it will create the Docker file, and then you can actually just run it using python main.py, which will serve not just the Ollama, but also it will serve the open web UI, which you are basically running. And you can see all of the requirements or txt file. So that's the thing with respect to the actual application code. So this is what will basically serve your application. And we also have some notebooks that are primarily for capturing OpenAI, which will be used for. So over here, what we're doing is that whenever you're actually sending a prompt to the actual application code, in this case, which we are basically doing it over here. So we are using LangChain. So LangChain is a really nice way for being able to interface with your large language models. So whether you want to create prompts or you want to actually create like entire retrieval augmented generation based chains. So LangChain actually allows you to do that. So all of those things behind the scenes, which are basically powering this UI application that you see, are being handled by that particular file. So again, simply what we'll do is we can either use the infra repository. So here what you'll see is that we have the Helm chart, which will be actually used to deploy our cluster. So here what you'll see is this is the deployment .yaml file, and we have the Helm chart that will be actually used to deploy it. And then we also have the LLM boilerplate code repository that will be used to actually go ahead and take all of the code that we have within this. So in this case, all the Terraform files that you see. So in this case, we have the different TF files for deploying the Kubernetes cluster, the firewall, the network, the Ollama UI, which you're seeing, which is the open web UI, and the actual like the Llama 3 model, where what we are essentially doing is that we are basically capturing the Llama 3 model that's deployed on top of Hugging Face, and then we are simply just pulling that particular image and deploying it. So let's go ahead and now we have set up our Terraform. We have set up our Terraform.tf force file. Now we'll simply go ahead and go to our infra directory and go to our TF directory over here, and simply again just use Terraform. So I think in this case also I don't have Terraform installed, but basically the steps are essentially the same, that you use Terraform inet, Terraform plan, and apply. So it will basically deploy the entire cluster. And the way that it will, again, this might take up to 15 minutes, and since we are short on time, I'll just quickly show you how that actually looks like. So I'll just quickly go ahead and probably start this Terraform, start this code space again. But the idea is that you just have to let the Terraform do its magic for you, and it will take care of deploying everything from setting up the GPU cluster and also setting up everything in between. And once you're done, so basically that is where you'll be able to see that also the load balancers automatically have been set up for you, the persistent volumes, all of those, and the firewall rules and the networking, the networks, all of them have been set up automatically with the help of the Terraform files that we just deployed. And the configuration of what these kind of look like, so all of those are actually typically defined inside of the variables.tf file over here. So in this case, for instance, this is the example where you see that all of before, again, those particular code spaces were active for quite a while, so they got reconnected. But the idea is that all of the files for the names of the actual cluster itself are defined in the variables.tf file. So for example, if you want to also then run some tests with your application, all of those will be present over here, including the deployment of the NVIDIA device plugin for adding the support for the GPU, right? So all of those are defined within this variables.tf file. So if you were to change the name of your GPU file, your cluster, you can directly go ahead and change this particular name. So we have some default values that have been set, as you can see. So if you were to change them, you can simply go ahead and change that config. And finally, what you'll see is that you have this entire cluster, GPU cluster, that's not only serving the actual Olama instance that is running the Llama 3 model, but is also running this web UI, which is being again connected with the Llama 3, which is now a deployable links. If all of you were to test it out, I think I'll keep it running for a short while, so you can simply go ahead and run this if you're interested. But that is a quick, yeah.
Shive, I was just going to add, wanted to take a quick moment to just appreciate the developer experience that kind of comes with the Civo Cloud Console and Terraform. It seems like, between the two tools, it seems like a very powerful type of developer flow, right? And I think, when you get into DevX, that really makes a difference. Managing these load balancers, like even trying to find a public IP address in Azure or Google Cloud or Amazon can be hard, right? And so I love how it's just like presented, because the whole time I'm thinking here, like, this is how I've done it on other platforms, and it's just so well composed. And I also like the developer docs that you showed us with the kind of pre-built examples and everything. Super robust, super easy to follow. Yeah.
And I think like this is where what I can probably do is if I have pieces running right now locally, let me go ahead and open up. Perfect. So I can also always go back to Copilot because I have the live context set up. So, I can perhaps, let's say I was editing that TF variable. So I can always now give a prompt to the Pieces Copilot with the live context, because as I was doing all of that demo, it had all of that context. So for example, if you were to now replicate that same demo, I can ask it, what were the steps, let's say, in order to run the name of the file, or we can probably try this out live, because we love live demos, so hopefully this should be able to capture that. But I can probably ask it, what are the steps involved in using Terraform for the Civo Llama 3, or I guess Llama Llama 3 project I was trying to deploy. So again, this gives you the power, because considering that when you're using something like Terraform, and if you're not new to it, right, so you might not be aware of all the steps. So hopefully, as we were able to as the live context was actually capturing all of the important bits of information that we were doing while we were busy with our deployment, it was capturing all of those important context information. So you should be able to answer that.
That's a really advanced question. I will be shocked if it gets this with your staging build, but wow.
There you go.
Oh my gosh, that's wild. I see right there, list, plan, deploy. It got the CDs that you were doing.
In fact, like it also gave me important information on, like, for instance, these 3 steps were basically if I were to deploy directly using the Terraform, but it also provided me additional context into that. Okay, because if you remember right, I first showed you that app directory where the actual source code is. So what the Terraform is actually doing is that it is capturing the pre-configured Docker file, Docker image that we already have on Docker Hub, right? But if you had a custom code, if you had a custom source code, like for example, you were not using the open web UI, you're using some other front end, like a Next.js front end. So you wanted to deploy your file, right? So first you'll have to actually build that image and then push it, and then go ahead and actually run your infra to be able to capture.
Yeah, and it's pretty wild how it all orchestrates together. Kunal, I just saw that question that you threw up there about costs, around training, quantization, things like that. I will say, at least from my perspective, the costs of Civo Cloud are pretty straightforward, to be completely honest. And I actually like that transparency. I will say we got a pretty large cloud build or cloud bill recently. So I saw that $1,500 number and I was like, wow, that's pretty rocking right there. But yeah, did you have anything else to add to that from the question earlier?
Yeah, no, I think someone was asking how do you reduce costs. So yeah, I think just optimize your model. We want. We also offer scalability, built in, so you can use horizontal or vertical auto scaling. And like I mentioned at the beginning of the session, the GPUs are like a third of the cost of hyperscalers. So Savo, if you run the same workloads on Civo, it's ideally like $500. But
probably so.
The billing is predictable, I would say, and transparent, and we don't have any hidden charges or fees.
Right.
But yeah, I think
I'll have to get with the ML team, and they're gonna have some things to account for sure.
And I know that previously, I think I did discuss with the ML team. I think they used to actually deploy ML models on top of Kubernetes with the help of Gki. So some of the larger embedding models that we used to run. But I think off late, we have not been really doing that. But I think it might be at least good to have a POC with, how Civo kind of handles it with the amazing DevX that we have. I know we are running short on time, but I just wanted to highlight one more thing, which is upcoming. Which is basically, one of the major aspects of something like what we deployed right now is a very basic Llama 3 model, right? But as you might have, let's say, a very complex pipeline. So something like at Pieces, it's not just like a large language model that you're interfacing with. Pieces OS itself ships so many embedded models, for example, right from the time when you're using the VS Code extension, let's say. So if you're using the VS Code extension, you're chatting with the Copilot and you're adding some files as context. First of all, you're doing a lot of embedding. So you're basically taking all of that source code that you have and you're generating small embeddings from that and then parsing it and then finally sending it to the Copilot. So we have so many of those embedded models. So considering that there is a use case where you are actually having a very complex pipeline, AI pipeline, where you might have multiple machine learning models. So just using a single GPU might actually not be suffice. And it also actually, one thing to keep in mind is that there are certain models that require more GPU compute, and there are certain GPU models that require less amount of compute. So the thing is that typically what ends up happening is that people with not much experience using GPUs, they might just have all of these GPUs running at all the times. And even if there is a smaller model that does not require complete access to the GPU, they're only using, like, let's say 10% of the GPU power. That 90% of the GPU power is actually getting lost and it's getting wasted because you're still paying upfront for it. So that is where technologies like being able to slice your GPU, which is known as GPU slicing, where you can actually take the same GPU and make multiple slices and then run individual machine learning workloads on those individual slices. So that actually ends up optimizing your GPU cost quite a lot, which is a great thing. And I know Civo GPU clusters are bringing in support for that. So this is also known as the dynamic resource allocation. So just wanted to quickly point it out because that is something that is extremely relevant, which is called as dynamic resource allocation. It's an extremely important concept within Kubernetes, and that's support for which is actually coming very soon to the Civo GPU clusters. So you'll be able to actually then have multiple GPU, like multiple AI workloads run parallelly together on multiple slices or multiple instances of these clusters, and that will also further help you save your costs associated with running a GPU based cluster. So just wanted to quickly point that out.
So it's like one GPU, it's being shared across multiple models. And that's kind of how you optimize, because no one wants to be paying for a bunch of A100s that are running in the background,
Absolutely.
Yeah, 100%.
Well, we're way 5 minutes ahead of our time, but we can quickly answer some of the questions.
Yeah.
How does the CI/CD process differ for AI/ML projects compared to traditional software development? I'd let other people chime in, but there are some other steps like Sava mentioned in the beginning, like there's data validation, model training. There's also hyperparameter tuning, model validation, so on and so forth. But yeah, go ahead.
Yeah, I would just say, normal CI/CD is like, push and hope, and then AI CI/CD is like push and pray. You know what I'm saying? It's like, CI/CD for the AI world is pretty crazy. I mean, it requires, much larger runners, if you will. And then the other thing to note is like, there's just like time, right? So, it might be 1,000 epochs in, and you're trying to like, check in, hey, are we converging or diverging on our optimization point, right? And so I think like normal CI/CD is a little bit less involved versus AI and ML CI/CD is, I would say it's kind of like interstitial, right? So you're like, hey, I want to exit out of this if I'm too far along, or it's not going well, right? Otherwise, that pipeline will run the entire way through. It'll cost a lot of money, and you'll come out with a model that wasn't, proper, right? And so I think like that's one example where, the human in the loop for AI and ML pipelines is much more involved than just your normal CI/CD pipeline, especially long running ones.
And I think like just one thing to add to this is that in something like a machine learning pipeline, you're also looking at experiments, right? Because you might have multiple weights and biases that you might be training your model on, and you're testing like which one gives you the best accuracy. So for example, like how we have Git version control, we have like data version control in the machine learning land. So DVC is like really great tool that allows you to do that, which allows you to now have multiple experiments and then run them. So you can have like separate CI/CD workflows running for each of these experiments as well.
Shive, I take it your laptop died? Or yeah, that's classic. No worries. That was graceful though. You just popped up and you're like, all right, there you go.
We have a piece of question on the screen.
Yeah. So the answer is absolutely right. And there's a couple ways that this occurs. Number one, your current context, right? So if you're using the Pieces Copilot inside of the IDE, it's going to be aware of like the folders and the files that you're working in. That's pretty nice. Number two is as you save materials to Pieces over time, it begins to understand like, okay, I'm Sabo. I work on a lot of Dart code. I work on a good bit of Rust code. And so when I ask a question, it's going to say, all right, like these are my default languages. These are my default coding styles based on the materials you have, right? And it could be, down to variable styles and naming conventions and whatnot, making that generative output a bit better. The last one there is because Pieces is aware of everything that's going on across the operating system. It can answer questions that, other models do not have an awareness of, right? Where it's like, what was I talking about with Mark related to this unit test that I'm currently working on in IntelliJ? And so it's able to connect the dots between what's going on in your collaboration environment and what's going on in your IDE, right? So there's a lot of different stuff there. We do have custom prompts coming, which is, basically you can stylize it. You can say, I only want code and I don't want any explanation, right? And so it'll save you a lot of words. Yeah.
Cool, amazing. I know we are a bit over time, so just to be cautious of everyone who has joined, let's just take one last question, which is, what are some of the emerging trends and technologies that are shaping the landscape of deploying on AI? Well, we covered quite a few. So there's, we mentioned Kubeflow. There's also other projects you can check like KubeEdge and Selden. Also like what Shive mentioned around
slicing. Yeah.
Slicing, I think that's one. And you also see people incorporating MLOps practices with like GitOps and like a bunch of stuff happening with CI/CD. Yeah. And I'm also really interested in like how AI is being used in the whole DevOps ecosystem. So maybe I've seen like companies doing incident management with AI. They're doing cost management with AI. So figuring out the instances that are going to happen before they even occur. I think that's going to be pretty cool. There are definitely a bunch of companies who do this. But yeah, what are your thoughts on the emerging trends and technologies?
Yeah, I think the number one thing is just cost savings, right? And I think like that's super important. And you're kind of seeing this like exponential increase in cost. And it's funny because we have limited hardware, right? You know, there's only so many silicon A100s or whatever we can put out there. Obviously, NVIDIA is doing very well with that. But you can imagine you kind of have like the entire crypto industry, which is GPU heavy, and you also have the entire AI industry, which is also GPU heavy. And so I think like that cost optimization component, starting with some of the bleeding edge stuff like CPU slicing is really important. I will also say like, with a lot of other compute capabilities, you have scale to zero and then scale up from there. And the interesting difference there is that the cold start on loading large models like a Llama 80 billion or Llama 70 billion or whatever is much greater than just the cold start on an AOT binary. So I think some advancements around, model kind of state caching will be really interesting, where your cold start is not as, heavy, which means you can scale those resources down and you can, basically only pay the cost of the first request. And so again, that just really comes down to cost optimization. Is how do we build products that aren't going to break the bank and charge our end users a ton of money, and also push down our margins as companies. I think that's really key. Yeah.
Yeah. Shiva, do you have anything to add? By the way, thanks for sharing, Savo.
Yeah, I think the only thing I want to focus on again is this DRA aspect, because I know so many companies are focusing on the dynamic resource allocation, and it's actually not just about being able to slice your GPUs, right? The other pertinent problem is that when it actually comes to deploying any sort of a large language model on top of native Kubernetes, the issue that we come up with is the batch-based scheduling of how the actual workload is being inferred, right? That is actually very slow. So that is where tools or technologies like VLLM, which is a virtual large language model. This is an open source project that if you deploy that on top of your Kubernetes cluster, that actually not only increases the inference speed for you, so it can show you impressive results all the way from like increasing or reducing the inference speed, reducing the time of the inference by anywhere from 25% to 50%, because now you're actually able to do a lot more compute in batches at the same time as compared to if you were doing it natively on top of Kubernetes. So there are definitely some issues in the platform, in the base platform, and that is why concepts like DRA and VLLM, and by the way, like there's a in the Google slides that I shared, there's an example of how you can actually leverage VLLM on top of Civo Cloud. And what you'll see is that if you were to deploy the model that we just deployed in our demo versus the one that if you deploy with VLLM, you'll see a huge jump in performance. So I think those are the two main things that I'm really excited for, because every major company today, whether it's NVIDIA or every major cloud provider, is basically working towards these two things.
Yeah. Thanks for sharing, everyone, and thanks for joining. This was really amazing. I'm sure you're going to see a bunch of clips of the highlights on Pieces socials. I still see to this date, like new clips keep coming out. I think it's good. But I think just last thing would be on my end, also the environmental effects. So nice to see when companies take that into account as well, like I mentioned with Deep Green. But yeah, you can join the Pieces Discord server. Just go to discord.com/invite/getpieces and continue the conversation over there if there were any questions that were left unanswered in this one. And lastly, there's the product hunt launch on July 10th.
Yeah, yes. July 10th. Yeah, we are hustling.
Yeah. So check that out. Make sure you give an upvote, set a reminder. Follow Pieces on socials, and you'll be reminded for all the latest updates. But yeah. Amazing webinar. Thanks for joining, everyone. See you in the next one.
Awesome. Bye. Thanks, everyone. Great work. Talk to you.